Venus. As we move towards the edge of the galaxy and stumble upon a yellow dwarf main sequence star at 100 million kilometers away from it, as we surpass the first planet in this star system, we find the closest thing to a literal hell in the universe. Earth's twin in this vast expanse of space. Similar in so many ways to our home world, the same size, the same mass, the same composition, both having a central core surrounded by a molten mantle covered in a thin crust, being birthed in the same protoplanetary disk 4.7 billion years ago, in roughly the same area of space and this vast universe, one at 100 million kilometers, while the other at 150 million kilometers away from the Sun, and both orbiting in the habitable zone of their parent star at some point. But at the same time, two of the most dramatically different worlds in existence. With no moon or natural satellite, like Uranus, Venus rotates in the opposite direction to the planets in our system. While all planets usually rotate in the same direction, being formed from the same protoplanetary disk, in the early life of our solar system, because our neighborhood was more congested, being full of small moon-to-Mars-sized objects called planetary embryos, one of the embryos managed to hit our planet in question so hard, in fact, that it nullified the initial, more dynamic momentum of the planet and made it to slowly rotate in the opposite direction, with a Venusian day having 243 Earth days, being longer than an orbit around the Sun, making a day on Venus more longer than a year on this planet. This orbit, as it overtakes our planet, makes it appear either at sunrise or at sunset in the sky, an observation that made Galilei deduce that the Sun and not the Earth is in the center of the solar system, one of the main reasons for his execution. Venus, named by the imagination of our ancestors after the Roman god of love, as it is the brightest object in the sky because of the proximity at its closest of only 40 million kilometers away from us. But as we grew up from the mud pond of knowledge of our past and started to evolve, we began to realize that our symbol of love bestowed upon it is far from the true nature of the planet. Instead, the symbol of Hades is more suited for the true reality of its being. An unsettling reminder of what our future looks like, as we are still bound by the forces of the cosmos. The most likely outcome that our Earth will experience if technology doesn't progress sufficiently enough in the next 600 million years as to change this natural faith of ours. A dense, thick, 91 times more heavier atmosphere than ours surrounds this planet, where we find the highest temperatures ever recorded in the entire solar system at over 462 degrees Celsius, made in the lower parts from mostly 96% carbon dioxide, 3.5% nitrogen, together with 0.5% other elements, unevenly distributed along a surface where in the higher reaches of the planet a highly reflective snow-like substance is found, all covered in its upper part by a layer of reflective, hellish, sulfuric acid clouds that make the planet blank and featureless when observed from above, and a nightmare of lightning and wind when observed from below. This extreme dense atmosphere prevents all meteors with a diameter of under 50 meters to reach the surface, being burned before ever touching the ground, while for those that do manage to reach the surface, because it doesn't possess any moon to produce tidal heating, and because of its extremely hermetic atmosphere, the impact craters remain very well preserved for a very long time, before another iconic event takes place on the planet, wiping out all of the over 1,000 craters that were discovered when the surface was mapped out using microwave radiation. Fresh lava flows on the surface, along with spikes in sulfur dioxide, indicate a geological active planet, with much of the surface being shaped by volcanism. Being 80% plains caused by lava flows alongside 150 volcanoes, each with a base of over 100 kilometers in diameter. This suggests that 300 million years ago, the entire surface resurfaced all at once, all the volcanoes erupting at the same time, spilling lava on every corner of the planet, creating along the way vast plains and highlands that remain impeccably preserved due to the atmosphere and peculiar geological dynamic. At the moment, the planet possesses two highland continents. In the north, one with the size of Australia, while the second, below the equator, we find the continent the size of South America. Unlike Earth, that reshapes the surface once every 100 million years through plate tectonics, on Venus there isn't a consistent or gradual process of convection currents, lacking any tectonic activity. As such, over time, heat from the core slowly rises over, which raises the temperature of the mantle, making it hotter and hotter and hotter until a global subduction event is caused, and the entire surface is swallowed all at once. Lava getting to the surface and forming an entirely brand new fresh batch of mantle, repeating over and over once every 500 million years. Just imagine the scenario. Being on the planet in that moment, the pressure squeezing, the degrees burning, winds and lightning everywhere, clouds of corrosive acid, and all of a sudden, hell rises from the depths, volcanoes spewing magma uncontrollably, the surface under your feet disappearing as the only thing that remains is a planetary ocean of molten rock. And it's real. It's no dream. It's no nightmare. It's the closest planet next to us. But it wasn't always like this. The sun fuses hydrogen in the core of its being, creating helium. As more and more hydrogen is depleted from the core, the sun becomes more inefficient over time, increasing the output and luminosity. More specifically, for every 1 billion year that passes, the sun increases its luminosity by 10%. Venus wasn't always like it is today. Once an oasis similar to the early Earth, with a shallow ocean and temperate climate that bare by its side for 2 billion years, that were lost as the sun got hotter and hotter, all of the water literally boiling away, thickening its atmosphere and provoking a runaway greenhouse effect so dramatic that it increased the temperatures to what they are now. In the early part of the solar system, the sun wasn't as bright as it is now, which made the habitable zone of the early solar system, where liquid water can appear on a planet's surface, to be much more closer to it than it is now. Back then, the early atmosphere wasn't so toxic, permitting conditions similar to those on Earth to arise. But let's go a little further back to understand more clearly. A few million years after the formation of Venus, as the surface cooled down, and geological activity along with impacts of asteroids and comets from the heavy bombardment period took over, slowly helped the planet to develop an atmosphere that was made mostly out of water and carbon dioxide. This early atmosphere protected and warmed the planet through a light greenhouse effect process. The gases being transparent, when visible light hit the surface, it was instantly reflected back out into space. But infrared light instead was absorbed by the tiny particles, gradually increasing the temperatures. Over time, clouds of water that was brought by the comets and asteroids developed, eventually reaching a point where it rained every single day for thousands and thousands of years, filling streams, lakes, and oceans with the water brought by these comets that survived for 2 billion years on this twin planet of the Earth. And because of the geological activity, hydrothermic vents present in the oceans created similar conditions to those of the early Earth, when life first started to emerge. Nevertheless, we can never truly know what happened regarding the presence of life due to the constant recycling of its surface, with all evidence being forever lost. For 2 billion years, the planet was an oasis in the universe. For 2 billion years, water was here, But as the sun increased in luminosity over time, the temperature in the solar system rose. As the temperatures rose, more heat was beginning to be trapped by the atmosphere. This rise in temperatures on its surface gradually started to vaporize the oceans. At first, the water vapors condensed in the upper atmosphere at higher altitudes and started to fall as rain, replenishing the oceans. But as temperatures further rose, by the time the water droplets were able to reach the surface, they have already evaporated, failing to replenish once more these oceans from which they came from. Adding insult, as there was so much water vapor in the atmosphere now, more and more infrared heat started to be trapped, further and further increasing the temperatures and igniting an irreversible cycle that eventually vaporized all the water on the planet. Venus doesn't have a strong magnetic field like Earth to protect the atmosphere. As such, all the water in the form of vapors over time got swept away by the powerful solar winds into space, leaving it as the literal hell for which we know it to be at the present moment. A glimpse of our future as the sun further increases in luminosity, if nothing happens to break the pattern of the cosmos. Although our neighbor is a planetary wasteland, scientists have begun to realize a potential there, and while probably not in the immediate future, but maybe as technology advances, Venus could once more see water on its surface. In the near future, scientists are hoping to send a special kind of rover to the planet, one that can withstand the extreme conditions and can collect valuable and comprehensive data about the dynamics that are present on its surface. While in the distant future, dreams of terraforming are being formed, or at least colonize the upper atmosphere, a place in the solar system where at 50 kilometers from the surface, the pressure is the same as on our own planet. Colonies of giant blimps, withstanding the intense erosion of the sulfuric acid as they drift away by the winds. But in the very distant future, if we fail to survive as a species and don't reach a level where terraforming and moving planets, at least in the solar system, becomes possible, then Venus will eventually be swallowed by the dying sun as it expands towards the end of its life into a red giant. A fate that will be shared by all the terrestrial planets if we don't step up our game and become masters of our surroundings. Okay. Thank you all for bearing till the end of this video. I hope you all enjoyed this episode about our sister planet, where I tried a different approach than the usual videos that I made so far, trying to speak a little slower. Thank you again for bearing this thing till the end, and until next time, take care.